How many structural isomers share the same molecular formula C8H10O? Ethers are excluded. Since the molecular formula's carbon to hydrogen ratio is approximately 1:1, benzene ring is present. Draw the ring with one substituent first. Focus on the first substituent, see if branching can occur. We have moved the OH group so that branching can occur. When branching adds to no further isomer, rearrange the substituents. We will realize that there are two substituents now instead of one. Place them closest to each other. Move one substituent at a time. Move the OH substituent from one carbon atom to the adjacent carbon atom. Repeat the movement of the OH substituent to another adjacent carbon atom to obtain the fifth isomer. When moving of the OH substituent leads to no new isomer, we will check if there is another pair of substituents available. There is a new pair. This time round, we will move the CH3 substituent, which is the methyl substituent, to the adjacent carbon atom. We repeat moving of the methyl substituent to another adjacent carbon atom to obtain the 8th isomer. When we realize that moving of the methyl substituent leads to no new isomer, we will check for a new set of substituents that is available. There is a new set. Place these three substituents closest to each other. Always remember to move one substituent at a time and leave the rest untouched. We have moved the OH substituent first, leaving the two methyl substituents untouched. Once again, we move the OH substituent to another adjacent carbon atom. However, this structure is identical to the 10th isomer. We'll move the OH, since moving of the OH substituent leads to no new isomer, we'll move the methyl or the middle substituent. Since moving of the OH and methyl substituents does not give me any new isomer, we will regroup the three substituents together. This time round, the OH substituent is found in the center. We will try to move the methyl substituent to the adjacent carbon atom, and indeed we will get the 13th isomer. However, moving the methyl substituent again to adjacent carbon atom gives me identical to 11th isomer. While moving of the OH substituent to another adjacent carbon atom, will actually give me an isomer that is identical to isomer number 13. Hence, to obtain our 14th isomer, we have to have the three substituents to be further separated from each other. Do check if the movement of the substituents produce new isomer. Check if there is any repeats. Since there are no repeats after checking, we can conclude that there are 14 isomers in total. Did you get all 14 isomers? Do replay this video to see whether you can obtain the 14 isomers and know the structure of these isomers.